Good morning, ladies and gentlemen. Welcome back. Today is Friday, February the 19th, and this is a mini lesson on inequalities. I do apologize, people at home watching this right now with YouTube. You have to actually download probably the inequalities worksheet that is found on our Brightspace. And for our class right now, Let's Live, we're going to take a look at a mini lesson on it. First of all, what are inequalities? You've seen this symbol before. This is the equal sign, right? And in fact, in our first unit, you've seen other inequalities. This one, notice we use this when it's a restriction, right? So this is unequal or not equal, right? Of course, many of you have seen this as children, greater than and less than. And of course, this means greater than or equal to, less than or equal to, right? So a lot of you know this. And from the drawing that you see from your handout, consider the inequality 8 is greater than 5. So a lot of you know that this is true. Now, how do I actually express 8 is greater than 5 on a number line? This point is clearly larger than this point, right? So the way that, well, in this question here, we're going to go with this. And what I've drawn, 8, wait, that's not right. 8 is not greater than 5. So this is that. 8 is greater than 5. I think that's what I wanted to do with this question. Oh no, we don't do anything with this. That's stupid. Sorry, 8 is greater than 5. I already forgot what this lesson was. I even made this worksheet so long ago. All you realize is this 8 is on this side, and it's clearly to the right of this 5. That's what I meant to show. Right? So, how do I fix this? I'll just put a box here. This box is completely right of that 5. Sorry, that's all you have to see. This is clearly larger than this 5. Okay, so now we got to actually take a look at proofs of working with inequalities. And now we're going to take this true statement, 8 is greater than 5, and we're going to follow along. And as you can see from the table, it says add 2 to both sides. If we add 2 to both sides, what do we get? Well, we get 10 is greater than 7. Right? And again, notice what it looks like. It looks like an equation, right, ladies and gentlemen from the class? It looks like an equation. But what you're trying to check to see if this is true. And it is true, right? This is true. Everyone agree? I think everyone's agree. Okay. How about the second line? Notice it says that 8 is greater than 5. And subtract 2 to both sides. Again, we subtract 2 to both sides. What do we get? Well, we get 6 and 3. And notice the inequality is still the same. 6 is still greater than 3. This is still true. I think a lot of you know what I'm doing, right? But let's keep on going. Let's see if you guys can do this next one. It says multiply both sides by 3. So one more time. We started with 8 and 5, and we're going to multiply both sides by 3. Right? And I think relatively easy. 8 times 3, that's 24. 5 times 3, that's 15. And I think everyone still agrees that this is true, right? So this is still true. So I think we'll keep on going. Let's divide both sides by 2. So some of you say, Mr. Chen, this is stupid. But there's a point. When you do 8 divided by 2, what do we get? 4. And 2.5. And notice, this is still true. So some of you say, Mr. Chen, what is the big deal? If we add each side, subtract both sides, multiply, what's the big deal? What's the big deal? I think some of you are realizing why I'm pausing, and if I'm off screen, I do apologize. You might have to pinch the screen to look a little bit closer. Pause the video, try to finish off the worksheet yourself, but hopefully that aha moment will come to you in a moment. But because I'm doing this live with the class, I'm going to keep on going. I'm just going to do the one below it, just to show you why. And we'll start off again with 8 is greater than 5. If 8 is greater than 5, I think we're on the second last row of the handout, and it says multiply both sides by -3. So if I multiply the left side by -3 and multiply the right side by -3, again, we get these answers of -24 and -15. But can someone in the class tell me, if I do this, is this correct? That is not correct. A lot of you realize that, wait a second, what are you talking about, Chad? 24 is clearly greater than 15. It is, in terms of magnitude. But this is not correct in terms of the number line. That is what I was trying to do over here. -24 is way down here, and -15 is way over here. And if we wanted to follow the same scenario of this number being greater, or this number being greater, it is clearly not. And a lot of you realize what I'm going to do. We flip the inequality sign to make it true now. So it's now true. Notice, what the lesson is showing you is twofold. One, when dealing with negatives and multiplication or division, the sign of the inequality flips. That's all you had to figure out for this last line. And hopefully it makes sense. Let's just make sure we're correct. Let's try dividing both sides by -2. 8 is greater than 5, and if we divide both sides by -2, what do we get? We get -4, -2.5, and again, if I were to do this, this would be false. -4 is clearly not larger than -2.5. So this is our answer to make it true. Let's pause for the class here. Are there questions of what I just showed you? In a nutshell, the golden rule is when multiplying or dividing by negatives to the sides of the inequality, the sign flips. And it only really affects these ones. One more time, what we're trying to say when we look at graphing questions, let's take a look at question 1 now. And again, none of you saw it, it says that in English here. If both sides of inequality are multiplied by a negative number, the inequality sign must be reversed. Let's try to graph this. And I'm going to erase this proof here, but any questions from the class right now? What we just did for the proof? Really straightforward. Our next part of the lesson then is to visualize these inequalities. And again, some of you find this weird, and that's okay, because you haven't really done it. It's been a long time since grade 9. Can I erase this? Cool. So, I'm going to leave that rule up there, and leave the proof. And again, the proof is just to make sure for understanding purposes what we're going to do. That. And for question 1 of our graphing now inequalities, for question 1, we have a number line, and that's why I just refer you so you don't have to worry about it. This is clearly 0. A lot of you realize the right hand side of the 0, it's positive, and to the left it's negative. So to show the first question, question A, which is really easy, x equals 3, some of you are going, what? You're used to graphing on a Cartesian plane where there's x's and y's. This is just a number line in, one direction. Sorry, one direction. Sorry. Anyway, x equals 3, what would you do? I think a lot of you know what this means. When x equals 3, it means to include exactly at 3. So a lot of you realize you've been trained this to put a filled in dot. So equal means to fill in. Now, if you don't like it, because I actually don't like this, I tend to put my dots or my values above it, just so that people can see the marking. So as a teaching purposes, I like to put it up top. I know it seems weird, but I like doing it like this. And if you see the handouts, eventually the solutions, they draw exactly on it, and it's also okay. Like there's answers on the back of the problem. I just like putting it on top so that it's a little easier for us to see. So for question B, it says x cannot equal to -2. And notice this funny looking syntax here. This is not a backwards 3. This is actually a Greek letter. Anyone actually know what Greek letter this is? Starts with E. Anyone from the class? Anyone taking Latin or Greek with Ms. Virgo? This is actually the symbol epsilon. Epsilon. Now you don't have to really worry about that, but I'm trying to tell you this is real. We tend to use Greek and Latin letters to denote some mathematical terminology. So it's kind of like emoji, right? Or short form. This actually means the elements of. Now some students don't know. What do you mean by elements of I? I don't even know what that means. So I try to do it colloquially. This really means belongs to. What does I stand for? I stands for the integers. A lot of you already know that the number sets, they have a numbering system. Whole numbers, natural numbers, integers, rationals, irrationals, complex numbers, real numbers, all sorts of things. So what we're just trying to show you with this, x cannot equal to -2 for complex numbers. Technically, this is the answer. In order to show this, and this is why a lot of you understand this when we teach the restrictions, x can be any number except -2. That's what that means. It's not equal to -2. So what are you going to do? Are you going to draw all the possible numbers? I think you would. Right? You'd say, Mr. Chen, at -1, it's this value, and it's this value, and it's at 1, and it's at 2, because we're going by the families of integers, right? But at -3, notice it's going to look like, I think it's a little, there's a gap there. So this is annoying if you want to show not equal to. So to get around this concept, don't get me wrong, technically this is correct, and you'd have to go forever, because the integers go more negative and more positive. The way that we show not equal, I know it seems weird, is to not include it. And so we use what's on open circle. One more time. Equals to means to include at 3. At -2, this basically denotes every other number, in fact, any integers, but it's just easier to show what is not equal to. So it's an easier way to just express that. That's why, one more time, when people say, like, let's just pretend only North Toronto students can, let's say even teenagers of North Toronto can only go to your party, only teenagers. Except Chen. No Mr. Chen, right? Like, you don't say, like John and Lisa and Mark, you know what? Everyone's invited to my Facebook group. Let's have a party, except Chen. So you know what you're gonna say? Chen, no Chen. No Mr. Chen, right? That means everyone's invited except for me. That's even sad thing, right? Who cares? But that's what that means, open circle, right? Question C, notice it says, and this is the hard one, x is less than or equal to 4, x belongs to n. N stands for natural numbers. So what are we going to draw for this one? And maybe I should use the color, just for orange. At 4, what does this mean? Well, x is less than or equal to 4, and it includes the 4, because that's what the equal sign means, and then 3, and then 2, and then 1, and then 0. The natural numbers go to 0. And notice, I just stopped there. So that's what you would show visually. That's why, again, for teaching purposes, I decided not to just draw on the number line. I went either above or below, just so that you could see it. So that you don't have to keep on drawing like 4 different number lines. Let's pause here for a second. Any questions on what I just showed? Notice again, some of you are understanding, but how come you didn't go to 5 or 6? Well, this means less than. So a lot of you realize, and again, that's why we show it. This means go in that direction, the left. X is less than or equal to 4. Oops. So question D, E, and F, I think you can try this yourself, but I think you can figure out. The last one we're going to do is question 2A of the practice. Okay? And I'm just going to write this over here. And notice it says for the instructions, solve each inequality, express your answer in interval notation, and graph the solution set on the number line. Now, this worksheet was designed for my enriched students, so you can ignore the interval notation. We're not going to teach you interval notation. Although it would be very easy and useful, we're only going to teach you the inequalities. And there is a reason why, okay? But for question 2a, x minus 4 is less than 0. And what are you going to do? Really easy. You're going to solve for x. But that's why I think some of you know what you're going to do. I'm going to add 4 to both sides. So a lot of you get x and 4. But because we did not do any multiplication or division with negatives, the inequality stays the same. So how is this going to look like? That's 0 and that's 4. The way that we're going to show it, oops, an open circle towards the left. Why towards the left? Because that's to be smaller. Why aren't you including 4? Because by definition, this means choose numbers that are smaller than 4. But 4 is not smaller than 4. It's actually equal to. That is why it's an open circle. In short, a lot of students understand, for the greater than sign, less than sign, or not equal, they're open circles. For the greater than or equal to, less than or equal to, or equal, they're going to be filled in circles. Let's just pause here. What you're slowly understanding is this is actually how we graph not just lines, but regions. Regions, like a front. Like, no offense if some of you played the Paradox game, Heroes, the Hearts of Iron 4. Sorry, Paradox strategy game. When you try to move your troops, you put the arrows and you try to show the region where they're going to advance. So this is like what we're trying to show, the inequalities. Let's pause here for a second. Any questions right now from the class? Okay, so I'm going to pause this video here or stop this recording. Holy cow, 16 minutes.